Hello friends, I welcome you in lecture number 25 on hypothesis testing. In this lecture, we are going to discuss about hypothesis test on the ratio of variances, or it is also known as F ratio test for the equality of two variances. Now to understand this lecture, you must be familiar with F distribution. You must be familiar with the sampling distribution of the ratio of sample variances. We have discussed in earlier lectures on sampling distribution that if we have two populations which are normal and independent, and suppose sigma 1 square and sigma 2 square are population variances and s1 square and s2 square are variances of samples taken from those two populations, then this random variable is a f random variable with n1 minus 1 degrees of freedom in the numerator and n2 minus 1 degrees of freedom in the denominator, where n1 and n2 are the sample sizes of samples which we are taking from those two normal populations. So you must be familiar about F distribution. You must be familiar about the sampling distribution of sample variances, and you must know how to use F distribution tables to find out critical values. So I assume that you are familiar with all these things, and with that assumption we can go for this lecture on hypothesis test for equality of two variances. So what we are going to do for this hypothesis test is, suppose we have two populations denoted by population 1 and population 2, and suppose we have sigma 1 square and sigma 2 square are population variances, and suppose we are considering samples of size n1 and size n2 from those two populations, and suppose s1 square and s2 square are the sample variances, and we are interested in the test of this equality of two population variances. We want to check whether sigma 1 square and sigma 2 square are same or different. So to apply this hypothesis test, we are considering two assumptions. First assumption is that both the populations are normal, and second assumption is that both the populations are independent. If these two conditions are satisfied, then we can say that if we take this ratio s1 square over sigma 1 square and in the denominator s2 square over sigma 2 square follows an F distribution with numerator degrees of freedom equal to n1 minus 1 and denominator degrees of freedom equal to n2 minus 1. Now here our null hypothesis is always this sigma 1 square equal to sigma 2 square. So because these two are equal, we have s1 square over s2 square as the test statistic for this F ratio test. So this test is known as hypothesis test on the variances, or it is also known as F ratio test for the equality of two variances. So we will always have this null hypothesis that sigma 1 square and sigma 2 square are equal, and we assume all those conditions that both the populations are normal and the samples which we are taking from those populations are independent. And as I discussed, if this null hypothesis is assumed as correct, or if we assume that this is true, then we have this formula for test statistic F equal to s1 square over s2 square, that is ratio of sample variances with n1 minus 1 degrees of freedom in the numerator and n2 minus 1 degrees of freedom in the denominator. And here I have written this s1 square and s2 square are the variances of two independent samples taken from two normal populations with variances sigma 1 square and sigma 2 square respectively. And rest of the procedure is same for hypothesis testing as we have done for earlier lectures. We start by considering null and alternative hypothesis. Then we see what is the level of significance given in the question. If it is not given in the question, we will consider 5% level of significance. Then we calculate the value of test statistic. After that, we find out critical values that will help us to decide the rejection and non-rejection regions. And then we compare calculated value of test statistic with critical value, and depending on that we take the decision that whether we will reject the null hypothesis or we will fail to reject the null hypothesis. So for F ratio test on the equality of two variances, what we have to remember is that we assume that this null hypothesis is true, and under this null hypothesis we have this formula for test statistic: F equal to variance of first sample divided by variance of second sample, and this follows an F distribution with n1 minus 1 degrees of freedom in the numerator and n2 minus 1 degrees of freedom in the denominator. So remember this formula. We will discuss one problem using this test statistic formula in upcoming lecture. Thanks for watching.